Hey guys, this is your review sheet for your Chapter 6 test. Let's go ahead and jump right through here. What is a polynomial function? Of least degree that has real coefficients and zeros of 3, 1/3, and 0. So this means x equals 3, x equals 1/3, and x equals 0. So this guy's finished here. This guy's going to be x minus 3, and this guy's going to be 3x equals 1. So 3x minus 1 is going to be your factor there. So what I'm going to do is take x minus 3, multiply that by 3x minus 1, multiply this by x. Okay? And if I actually do all this multiplication, I'll have my function. So this is 3x squared, and that would be negative 9x minus 1x is negative 10x plus 3. And multiply that all by x. So my final function would be 3x to the third minus 10x squared plus 3x. There you go. Jumping over here to b. Okay, so x minus 5 equals positive or negative 2i. So I've already isolated that guy. This guy's x minus 2 equals 0. Now that meant that x minus 5, I took the square root of negative 4 to get that. So this is x minus 5 squared plus 4 equals 0. And this stays as is. So what I'm going to do is I'm actually going to FOIL this. This is x squared minus 10x plus 25 plus 4. So I'm actually going to have x minus 2 times x squared minus 10x plus 29. All right. Now, in brown, I'm going to multiply x in here. So that's going to be x cubed minus 10x squared plus 29x. As far as multiplying the negative 2 in, okay, I'm going to do negative 2x squared plus 20x minus 58. So my final function, for f of x, is x to the third minus 12x squared plus 49. Wow, I just cleaned it up a little bit. 49x minus 58. Okay, so there are your first two. All right, hopefully that will help you out. Jumping down to your graph problem here, below is a graph of a third-degree polynomial, which means it was x to the third, so it's a disco problem. So that's why you see one low, one high. Complete each blank. How many real roots does the function have? Well, 1, 2, 3 real roots. That will leave 0 for the imaginary. You always count the real roots first. So if we were going to do a problem that looked like, I don't know, let me do it in red here. We had one that was an x cubed. Yeah, I hope you're laughing at me. So. If I actually do that, and I say, hey, it hit once, this answer would be once, which means it would have 2 imaginary roots. So there's 2 examples for you to look at, okay? All right, going down here to 3 with your infinities. This is the one that we just covered recently. Okay, this is an odd power with a positive value. This is odd. Check to make sure that this is the highest degree. So make sure you look for the highest degree. All right, so if you put negative infinity in here, you're going to get a negative number times a positive, which is negative. So negative infinity will go to negative infinity. If I put a positive infinity in here, it'll be a positive, which gives me positive infinity then as well. All right, so you'll see 1 or 2 of those on your test. Okay, so let's take a look at 4a. It says the width of the rectangle is tripled, so that's 3w, and the length is reduced by 1/2. So I'm going to do length minus 1/2. What can be said about the area? Well, the area of a rectangle is usually length times width. So that's the original. The new one would be 3 times w and L minus 1/2. So I'm going to distribute this in. This is 3WL minus, well, I guess 3 over 2W. Okay, so what can be said about the area? Okay, it's 3 times minus 3/2 W compared to the original. If the height and length of the rectangle box is quadrupled, so we're doing quadrupling, so 4 times the length, height and width. So 4 times the height being quadruple, what can be said about the volume of the box? Volume is length times width times height. So if that's our original, and mu is 4L times W times 4H. So this volume is going to be 16WLH, so 16 times larger. Okay. If the radius of a cylinder is 1/3 its original size, so radius times 1/3, that's our new guy. What can be said about the volume of a cylinder? Well, the original volume is pi r squared cubed, pi r squared h. The new one's going to be 1/3 r squared that times h. So, if I square this, this is 1/9 r squared times h. So it would appear to be 1/9 of the volume. Okay, so it's 1/9 of the original volume. All right, let's hit for 4. Let's go to 5. We're using synthetic substitution, so we're going to have 5, -2, 0, -15. Please note there are 0 x's there. So this is 15, 13, 39, 117, I believe. All right, and that will leave me with 102. Okay, so 102. So it looks like f of 3 equals 100. Given 1, 0, the polynomial function, find the other zeros. I'm going to start with synthetic division here to see what's left. Doesn't look like they skipped any places. So this is 3, 15, -1, -5, -2, -10. Good, should be 0. This is 3x squared minus 1x minus 2. So I want to factor that. So I'm going to use Texas method. I got factors of 6. So I have 3x squared plus minus -2 equals 0. I need a difference of 1, and I need it to be negative. So 3x would have to go here, 2x would have to go here. Factor out an x, that leaves me 3x plus 2. Factor out a -1, leaves me 3x plus 2. So my first factor in 3x plus 2 is equal to 0, and the x minus 1 equals 0. So he is positive 1. This would be 3x equals -2. X is -2/3. So all your zeros would be x equals 5, 1, and -2/3. That would be it. Allows me to jump to number 7 here, use the rational zero theorem in synthetic division to find all the zeros. So let's start with P. P is 0, Q is 1. PQ. So it does appear that 0 is a factor. So let's actually see here. Rather than do PQs, I notice that this is actually factorable. So I'm going to pull out an x third, leaves me with x plus 3. I'm going to pull out a -4x, that's going to leave me with 1x plus 3. Alright, so in the front I have x cubed minus 4x, and I have x plus 3. So this one's not bad, he's -3. This guy, pull a GCF out, I get x squared minus 4, so x equals 0, which is one of our factors if we did p over q. Okay, so I still have to factor x squared, x plus 2, x minus 2. So it looks like x is -2, +2, -3, and 0. I have 4 solutions. I had 4 as my x. So I actually didn't have to use rational root here. But if I did, sorry, I didn't mean to write x there. We want 3, negative 4, negative 12, 0. So this will be 1, 0, 3, 0, negative 4, 0, negative 12. This is 0, 0. So here I would have had x to the third plus 3x squared minus 4x minus 12. And I'd still be doing a GCF, x squared, x plus 3, negative 4, x plus 3. You can see I'm ending up right where I was at. So I'd actually let you pick there. Okay, last problem. We want to know what h equals. Okay, they tell you the volume is 6x to the 5th plus 18x squared to the 4th minus 14x to the 3rd minus 42x squared. Now, so here's my volume of the entire item. I'm going to set that equal to what I know. So volume is length times width times height. So my length would be x plus 3 times 2x squared times whatever h is. So if I solve this for h, I'm actually dividing this by x plus 3 to 2x squared. Okay, so this is x plus 3 times 2x squared. So if I wanted to do long division here, which this is what I would actually prefer, 6x to the 5th, 18x to the 4th, minus 14x to the 3rd, minus 42x squared, plus 0x's plus 0. Divided by 2x to the 3rd plus 6x squared. So what do I multiply 2x cubed by to make it 6x to the 5th? I'm going to multiply it by an x squared, and I'm going to multiply it by a 3. So this is going to be 6x to the 5th, 18x to the 5th. He's gone. So what's left is negative 14x cubed minus 42x squared. So 2 times what is negative 14? 2 times negative 7. And that's all I need, because negative 7 times that is negative 14x to the 3rd minus 42x squared. Subtract that, and get 0. So my height would be 3x squared minus 7. Okay? So there's your review sheet. It's kind of quick, short, to the point. If you have questions, email me. Make sure you guys take a good look at this, so that way you're ready to go on your test. Know what a cubic is, know what a quartic is, okay? Know that anything to the 3rd power is a cubic. Anything to the 4th power is a quartic. Okay, so you should be ready to go. We'll see you guys on test day. Take care.